Hey y'all, welcome back to the channel. In today's session, we're going to talk about the new model from Anthropic that just got released yesterday. And shortly after that, just a few hours later, AWS came out with the support for the new Anthropic model in Amazon Bedrock. So today, I would like us to take a closer look at the Anthropic Claude 3.7 Sonnet, talk just briefly what is so special about it, and then I would like to show you four different ways to interact with it. One via the management console, and then three different ways interacting through the AWS SDK for Python programmatically, the ways that you would use to implement the applications that rely on this model. Along the journey, we're also going to talk about how you set up the permissions to very quickly, very rapidly experiment with this new model. There was a blog post that got published just yesterday that introduced Claude 3.7 model. So let's jump straight in and talk about what is so unique about this model. If you are new to this channel, please consider liking and subscribing. That way, as I continue to make these videos, you'll get notified and see that there's something new, interesting for you to review. So let's dive in. What is so special about this new model from Anthropic? Now, a few key distinctions from the previous version of the model, Claude 3.5 Sonnet v2. That was the most recent model available from Anthropic, from the Sonnet family at least. And 3.7 Sonnet adds additional capabilities to what 3.5 previously had. Specifically, it comes with this hybrid reasoning where we have ability for only this model here to specify whether we want the standard mode or if we prefer to use the extended thinking mode where Sonnet engages in trying to think about a problem in a bit more depth, kind of similar to what DeepSeek was doing. If you have missed the DeepSeek video, make sure you check out that video as well. I walk through how you can host DeepSeek on Bedrock and SageMaker in that video. There was actually the first video on this channel. Now, with Claude 3.7 Sonnet, we have ability to, in a similar fashion, enable this type of deeper thinking. And I went through the blog post and summarized the key takeaways in the recent LinkedIn post here, where I mentioned that if you want to get started here, the hybrid reasoning allows you to those two options. The first mode, the standard mode, is practically just an improved version of Claude 3.5 Sonnet. So 3.7 Sonnet just looks and feels like 3.5, but it comes with various improvements across different benchmarks there. And then specifically in the extended thinking mode, 3.7 Sonnet takes an additional time to analyze the problems in details, and that is going to lead you to consider multiple perspectives, and specifically for coding tasks and for the math problems, it's going to do a better job coming up with the good quality response. It's a bit more depth in thinking. So keep in mind that while this is going to improve the performance in coding and math problems, it is going to also come with some additional cost because the model is going to be, as part of that deeper thinking process, it's going to be processing more tokens. So that's something that you want to make sure you don't miss there, because it will lead to higher costs. So you don't want to be using the extended thinking mode for every problem for two reasons. One is the cost that we just mentioned, and the second reason is the latency, as you will come to find here shortly when I walk you through how to set things up and how to use it. There's substantially more latency involved with the using the extended thinking mode. So with that, why don't we jump straight in? I've published the full walkthrough to a GitHub repository. I'll include all these references that we're discussing here in the description of the video, so you can easily clone this repo, review all the other documentation pages, and replicate what I'm going to show you here. So before we go through that process, the the early stages of the example that I'm going to walk you through is going to involve importing the libraries and setting up the permissions. So let's just go ahead and do that. I'm going to just minimize the side bar so we can see a little bit easier here. And let's import those libraries. Now the next part is going to require us to have a profile set up. And this is generally the best practice. You do not want to be hard coding credentials in your code. So when you push any changes to a remote Git repository, you're not exposing your credentials. So what we need to do next is we need to just set up this profile for developers. So let's go ahead and create a user that will give us the credentials that we can set up as this particular profile. And this is going to be a very, very quick process. So what I'm going to do here in the management console is I'm going to go to Identity Access Management Service, and I'm actually going to head straight to the users section of it. And I'm going to create a new user. I'm going to give it a name. So let's call it Alan Turing as an example here. I'm sure he'd have a blast being around in this LLM era. And we're just going to follow the naming conventions here, and we're going to add this user to a group. Now I have one user group already created, AI developers, that has the Bedrock full access managed policy attached to it. So this is going to include all the permissions we need and more, right? In reality, you want to, in production use cases, you want to strip down these permissions to only the APIs that your application needs. In this case, this is a sandbox dev environment. We want to be moving a little bit quicker, so we're going to be using this a bit more permissive policy there. So let's go ahead and add this user. This looks all good, and let's go ahead and say create. Now I'm going to take that user, and I need security credentials. So I'm going to go to the security credentials tab, scroll down to the access keys, and create an access key. I'm going to specify that I plan to use these through the command line, and the management console tells me about some of the alternatives like Cloud Shell there instead. So I'm going to say, that's okay, thank you for the recommendations, but I'm still going to proceed with creating this access key pair. I don't need any tags. I'm going to say create access key, and I get the key pair, access key and secret access key. So let's go ahead and configure these in our environment so we can set up that dev profile that we plan to use. To do that, I'm going to pull up a terminal in my IDE, and I'm going to say AWS configure, and let's set up the profile dev. I'm going to specify that access key as the access key ID, and then I'm going to select the secret access key here as the secret access key that needs to be entered in here. So let's go ahead and enter that. I'm planning to delete this user as soon as I finish this demo, and by the time this video goes online, it'll be long gone. But in reality, you never want to share these details with anyone there. So I'm gonna say let's use that. Let's use US East 1 as my home region, and use the output format of JSON. Now, this just created a profile. If you are looking to find the credentials, they're going to be in the .aws credentials file. And if you are, in fact, I can show you these both of these files here, and the config file right here is going to okay, so I'm currently in the project directory, so we'll need to actually step out of there. So let's do this instead. Okay, so this is the home directory, and I can do the .aws here, and you can see, in fact, you can see that there's the config file and the credentials file. So all the details that we just entered around that profile have been stored in there, which means our IDE is going to be able to recognize it and be able to use it. So let's go ahead and do that, so we can continue now that we have our profile set up. We're going to set up a session. again, specifying best practice, what the region is, and we're going to say that this is going to be the dev profile that we're going to be using. So at this point in time, the SDK and my ID through the SDK has discovered those credentials, and it's going to be using those to interact with Bedrock service. So let's go ahead and start creating a client. Whenever you create a client programmatically here, you are going to need to set up the client for control plane operations and for data plane operations. So what I mean by that is anytime you want to, let's say, list models that exist in Bedrock, you're going to use this Bedrock client. Anytime you want to send inference requests to invoke models, you're going to be using the Bedrock runtime client. Those two control plane and data plane operations have been nicely separated through the usage of these two different clients. So let's run this cell so that we can have these two clients instantiated. And at this point in time, we want to see what models are available. Now, in this code here, I'm going to show only the first 5 model IDs, because otherwise the output would just be humongous if we didn't do that. So let's run this to see what the output looks like, and you can kind of see the model ID, the name of the provider, and the name of the model. These are just some of the metadata elements that I decided to print here. So if you want to interact with Bedrock programmatically, you would need to know what these IDs are. Now, something that is interesting about the Claude 3.7 Sonnet is that it doesn't allow usage through on-demand capacity by going directly to the model ID. What you need to do instead is use the inference profiles. And similar to how we have model IDs, we also have these inference profiles, a variety of them for different models that allow Bedrock to distribute the requests across different regions depending on where the capacity is available. So you can see just the first few examples of models like Claude 3 Opus, Claude 3 Haiku, Sonnet, and so on. And similar to the model ID, these are going to have inference IDs that we can use specifying the same way. In fact, we're going to be specifying them as model IDs to our clients that we use to interact with the Bedrock service. So at this point in time, we want to make sure that for this model that we plan to use, that we have access to it. And I included a set of screenshots here. If you haven't done this before, it's very easy and quick. It takes just a few steps to complete, and it's done through the management console. So let's briefly take a look at how we can accomplish that. I'm going to navigate back to the management console, and this time around, we're not going to need this user anymore. I'm going to close this, and I'm going to, in Bedrock service, navigate all the way down to the model access. And you can see one model is there new. So if you go to model access, there's 48 models in this particular region, in Northern Virginia region, that you have ability to use through Bedrock service hosted in a serverless fashion. Now, if you just search for the model of interest, I'm going to search for Sonnet to make this quick. You can see that the Claude 3.5 Sonnet is 3.7 Sonnet, is on the list. And I've already went through the process to request access. The first time around you're doing this, you will need to request access. And the way that you will be doing that is by saying modify model access up here. You will then select which models you want to add. In your case, you need to make sure you check this checkbox for Claude 3.7 Sonnet. And then as we scroll down, you're going to have the next button. It's going to show if there's any modifications. In this case, it's not allowing us to proceed because I'm not making any changes here. But let's say that I'm going to remove maybe one of these AI21 labs just so you can see what the next window looks like. I'm going to say next, and it's going to say, okay, what is about to change? In this case, we're removing access for this model. In your case, it will say you're adding access, enabling access for Claude 3.7 Sonnet, and you can just say submit to activate that. pretty much instantaneously, the access is going to be enabled there. And that, aside from having the permissions to invoke the model, which is set up through identity access management and those policies, you are also going to need to make sure that this step is done there. So I've included those screenshots if you ever need a reminder in that Git repository, that example that I provided there. And at this point in time, you can even go through the playground. We can go go back to Bedrock service, and we can navigate to the playgrounds chat/text. I can select that Anthropic model, Claude 3.7 Sonnet, which is listed here as new, and I can say apply right here. So it allows me to set up the typical inference parameters that you've seen the previous models require as well, like system prompts, or I should say offer, because system prompt, for instance, is optional there. Temperature, top P, top K, but now with the 3.7, you scroll further down, you see model reasoning available there as well. So we can ask it a question, for instance, what is so special about extended model thinking feature of Claude 3.7 Sonnet model? Just ask it that question, and you can interact with the Claude 3.7 Sonnet there. So it's going to return a response in the Markdown format, and it's going to talk about some of the key features there, and what is why this is beneficial, why we would even want to do this. And the response was pretty quick. You can see the latency here says 10,917 milliseconds. There is what it took, even though it didn't feel like it was that long there, but this is really just maybe about 10 seconds here that it took in total. Now we can clear this, and we can choose to enable the model reasoning, and this is where when you enable the model reasoning, notice that some of the parameters get grayed out, and this is going to come back later on when we take the programmatic approach, where instead of the UI doing this for you, you need to know what needs to be set to what values. For instance, the temperature has to be set to a value of 1 when you use the extended reasoning. And if you try to perform extended reasoning programmatically through the SDK, like I'll show you here shortly, with something else set as the temperature value, you're going to get an error back. Similarly, you also need to make sure that top P and top K are stripped from the inputs. They don't need to be provided. And you can see here they're basically removed. You need to make sure you do the same when you are sending inference requests with this extended thinking feature programmatically as well. So we can now share the, also we can specify the number of reasoning tokens. So this is going to impact our cost. In other words, how many tokens the model is going to be using for those intermediary thought processes before it generates the final response. So you can modify this. In fact, we can set it to a little bit of a larger value, like maybe 4096. It looks like is the maximum value here in the playground. Programmatically, you can set this to larger values as well. So let's paste the same question as before. What is so special about extended model thinking? Feature of Claude 3.7 Sonnet. And we're going to run this, and now it says the model will return the following errors. Max tokens must be greater than thinking the budget tokens. These are the budget tokens here. So let's go to maximum length, and let's increase that so we can fix that problem. I'm going to set it to maybe 10,000 here, because the maximum length is the maximum length that will be generated by the model. These budget tokens, which are here listed as the reasoning tokens, are going to be those intermediate results. So you can't have intermediate results be greater than the total output length that we specify. So let's run this again, and I'm going to just close this. And you can see now it's reasoning through the response. It's going to kind of think through how to go best about to understand what are the key points, dive a little bit deeper into it, and it's going to take longer. It's going to take noticeably longer. You'll come to find that when we do this programmatically as well, you'll need to have some sort of loop to make sure that this is or dedicate appropriate amount of time for these reasoning inference calls, which take substantially longer to complete. Now, if we scroll further down, it looks like it's ready. So this is going to be the final response listed below with the key benefits, practical advantages, and so on. But you can see what comes before that is this reasoning, which you can expand or hide. And this is where the model says the question is asking me about the extended model thinking feature of Claude 3.7. Let me share what I know about this feature. Thinking, and then as it goes through this process, it's going to question itself. It's going to try and see things from a different perspective, and that is going to take quite a bit more time. You can see it takes 3 times as long to compile the response. And this is not even a difficult question. Now, if you ask it a question from the very difficult question from the math or coding domains, it's going to take substantially longer to come back with the response. So you can interact with it in the playground, but ultimately we're going to be building applications programmatically. So let's take a look at how we can interact with this new model using the SDK in a few different ways. So the first way that we're going to explore is just going to be a simple inference that we perform. So this is going to be sending an inference request. We have a helper function, create request body, which takes several arguments here. And by default, it's not going to be using that extended mode. By default, it's just going to be performing the standard inference, which leads to the Claude 3.7 to behave as just an improved version of 3.5 there. And we're setting some of the default values to for thinking budget, just in case if this is not specified when the extended mode is utilized. So if we scroll further down, we see that we are compiling the request, and then depending on whether the extended mode is being requested, we're going to add this thinking block to the request as well, which is going to say that thinking is enabled and specify the maximum thinking budget, which by default is going to be 8,000 unless a different value is provided there. We're going to convert that to JSON as the API expects it, and that's going to return the full request that can be sent to Bedrock service. Now, aside from this little helper function that helps us compile the request or put together a request, we also have, in this case, have another helper function that's going to parse through the responses from the model, because the model returns the encoded response with various other metadata elements. So I'm going to be focusing on just unpacking the content of the response and returning that, so we can easily see what is the actual response from the model itself. Set aside all the other metadata elements that Bedrock returns. This is where I said here that when we that you may get this error here if you, since Claude 3.7 Sonnet on demand is currently only available via inference profiles. So you need to make sure that when you follow along, just follow along what I have here. Do not enter the ID of the Claude 3.7 Sonnet. That requires provision throughput. What we are using here is the on-demand mode, which you need to which you need to specify the inference profile for. So if you go to the documentation page, and let's just briefly go back here, documentation page where it says supported foundation models in Bedrock. This is where you'll find various IDs. So let's just search for Sonnet here, find Sonnet 3.7, and should be right below here. Let's see, yeah, right here. So this is the model ID. This is not what you want to use. You don't want to use this because that is going to be requiring the provision throughput. What you want to do is what we listed previously in the upper when we listed the inference profiles. So one of those inference profiles specifically for Claude 3.5 Sonnet will be this particular ID, which is not the model, the LLM, the model ID. If you want to have also a quick lookup via the management console, we can go back into the management console, and there you'll be able to see the inference IDs as well. So if we take a look at the model catalog here, and let's just search for serverless and search for Sonnet. Here, 3.7. Let's open it up. And let's see if we're going to be able to see that value here. Okay, I don't see the inference profile here anymore. The UI may have been redesigned, but again, if we go back to the code, you can programmatically get inference profile for any model there. So if we scroll back to available foundation models and right below the snippet where I say available inference profiles, this is the way to retrieve the inference profiles. You just call list inference profiles, and then you can filter for a particular model there. So that is what we want to use, and that is what I have configured in my example right here. Okay, so let me make sure I'm running these cells, because we'll need these helper functions that we reviewed. So in other words, if you get this error, just know that you're using model ID and you should be using the inference profile. That's why I included it here. So we're using the inference profile here, and we're going to run this request, specify the prompt. How would you distinguish between understanding language and simulating understanding, right? That's a debate that is ongoing in the community. To what extent do models understand versus just mimic what we're doing? So we're going to use that create request body, the helper function, to create that complete request, providing the model ID, which is that inference profile, and the prompt. And then we're going to invoke the model using the Bedrock runtime client, specifying the model ID and the request body as well. Whatever we receive the response is going to get collected in this object here, and we're going to use the other helper function, the second one, to parse through the output and be able to see the response. So the model response is going to be here, listed right here. It's going to say understanding versus simulating understanding, and then it goes on to talk about this is a profound philosophical question that touches on consciousness and AI, and then it goes on and talks about it. So this is still the standard mode. We're not asking you to dive very deep into these topics. So that is the first way, a very, very simple way of interacting with the model. Now, the next thing we want to take a look at before we explore the option to do the extended thinking is the streaming inference example. So you've noticed here that we had to wait for a few moments for the entire response to be returned. If you like to have that streaming experience, like what you see in some of the front-end apps when the models are generating tokens, that can be accomplished here as well. We just need to use a different function that is mapped to a different API or Bedrock service. The steps are going to be the same. We're just going to be using the invoke model with response stream. And I'm asking here a different question, just for variety purposes. Can a system trained on human text develop novel ideas, or is it fundamentally limited to just recombining the existing human thoughts? So another a bit more philosophical question there. So with that, we're going to, once we collect the response, we're going to have the stream store the body of the response, and then we're going to be printing the chunks of the stream. So I have this loop here that is going to go through all the chunks that are being streamed and print them individually to just simply show you how many chunks are being streamed. That you can imagine in your application you'd be streaming them in a horizontal fashion, so the end user can easily read the response. Here I'm just printing them as the blocks of chunks so that you can easily see how this works. And then in the end, we're going to print the consolidated response, which is going to be that full block that got generated. So as we run this, you can see the chunks are now being generated as the response and as the model is generating the response. So that again allows us to stream the response back, so the end users don't have to sit there and wait for a few seconds to see anything on the screen. And then in the end here we print the consolidated streaming response, and this is the consolidated response that we kind of have put together. So depending on what type of an application you have, if you are working on users, having end users interact with the model, then you definitely want to stream the response back, or if they're using some sort of a chatbot experience. On the other hand, if you are using this for some sort of backend process, you don't necessarily need to stream responses. You can just generate the entire response with the first method we discussed, and optimize the throughput by pushing everything at once. Okay, so this is the second approach to working with the models in Bedrock. And as we can see, we can use it to interact with the 3.7 Sonnet as well. Now, let's take a look at how do we expand what we've done so far to enable the extended thinking mode. Now, the helper function we've set up earlier, as you remember from a couple minutes ago when we looked at it, has a particular condition to see if the thinking mode has been set to extended. If it has, it adds another part to the request body to specify that to Bedrock. So we're going to use that same create request body approach, but now we're going to set that thinking mode to extended. And then that is going to lead to the model to, first off, take substantially longer to come up with a response. So let's just go ahead and run it here while we're chatting. And the prompt here is going to be, are there an infinite number of prime numbers such that n mod 4 equals 3. So that is a much more in-depth, much more difficult question than, hey, what's so special about Claude Sonnet 3.7? So this is going to be a substantially more difficult question, and this is specifically, according to Anthropic, what this extended thinking mode has been designed for very difficult, very in-depth coding and math problems primarily. So you can see this is still running. It's been about 40 seconds now, and it's still not done. And the reason for that being is that it's trying to practically generate all those intermediate steps and then use that to arrive at the best possible output that it can generate. You can see here I've ratcheted up the number of maximum tokens that can be generated to 24,000. I set the temperature to 1 because that is a requirement there, and I also included the thinking budget of 16,000 tokens. So as you saw through the playground, we need to make sure that the thinking budget is smaller than the max tokens because thinking budget is just going to be the subset of everything that gets generated by the model. So that superset needs to be just a greater number there. So this is still running. You can see it's a minute and 35 seconds. My guess would be that it's probably going to take maybe another 20-30 seconds here to complete. So we may find the response here shortly, but we haven't, as you saw here, we haven't modified the code at all. We've just enabled that extended thinking mode there. And we can see here in the response that when you use the extended thinking mode, by the way, it took about a minute and 47 seconds. So substantially longer than just a handful of seconds that the previous standard mode took. So when you have the extended thinking enabled, the response is going to, aside from the final response, which is going to be of type text, also include a component of type thinking. And that component of type thinking is going to have the thinking structure here that describes exactly what the model was doing, how was it thinking about this. So as we said earlier, similar to what DeepSeek has done, implemented differently in this case, but the similar approach to trying to solve a problem by thinking about the problem in a bit more depth. Again, if you haven't seen the DeepSeek video, I'll include a card here so you can easily click on the link to see that video as well. I think you'll find some of the similarities there as well. And then this block here, type text, which you always get in standard mode as well, is the final response from the model. So in the management console, in the playground, when we hit that reasoning component, that reasoning component is the of type thinking when you interact programmatically with the model. And I left all these responses in the Jupyter Notebook on purpose when I pushed it to the Git repo. So if you are not going to be running through this, you can at least skim through the responses to familiarize with what you can expect there. Now, the next part that we want to see, the next way of interacting with the Bedrock service, specifically for this model, but this can be applied to other models as well, is using a different API. So we're not going to be using the invoke model API or invoke model with streaming response. We're using an entirely different API that's called Converse API. The primary superpower of the Converse API is that it allows you to keep track of the entire conversation, all the relevant requests and responses from the model. And then it also standardizes the names of inference parameters for models from different model providers. Because, Anthropic may call top underscore P. Amazon with its Nova models and Titan models may call top P top capital P, right? Minor differences there that leads to unnecessary code changes for developers that are looking to kind of swap in and swap out to different LLMs. With the Converse API, you have a standard interface, and you can just keep swapping the LLMs that are being used in the conversation. So I've created here another helper function, generate conversations, that allows us to set various arguments are going to be passed to it. And in a similar fashion, we're going to have a block that's unique to extended thinking mode, where we're going to go in and update some of the parameters. So you can see here I'm setting the temperature parameter to 1, and I'm going to remove top K because top K and top P are not going to be we're not going to be able to provide them when we use the extended mode. So we need to make sure we strip this, because if you provide this programmatically, you get an error response back saying that extended thinking mode should not have this element provided to it. So we have a little bit of a logic here to update what the existing request body looks like, and we're going to add the thinking block in a similar fashion to what we've seen previously, specifying the thinking budget there as well. So when we call this API, we're going to call the function converse from the Bedrock client, which is going to allow us to run this example. So let's go ahead and do that. And I'm printing some of the usage here around the number of input tokens, output tokens, so you can kind of see how we can strip that from the response as well. So let's run this cell so we can have that helper function created. And then I'm going to, in this case, also show you an example how you can have multiple messages and the system prompt being used. So in this case, I said you're a philosopher delving into the study of consciousness. Only discuss safe philosophical topics, right? That is the system prompt to the model to make sure the model doesn't deviate during the conversations. And then messages that we want to work with are the first message, how would you distinguish between understanding language and simulating understanding, which is there from before. The second message we're going to provide to the model is there any potential interesting angle that you haven't considered there? So we're going to append to the list of messages the first message and call generate conversation helper function to send that to the model. The model comes back, returns a response. We have that response. We're going to add response, the output message from the response. We're going to append that to the messages. And then we're going to append the next message we want to send to the model, send that to the model, collect the response. And ultimately what we're doing with these appends is maintaining the conversation history there. So that is going to allow us to, as the conversation is ongoing, to have the full history of what was done, which is helpful from the tracking purpose, but also helpful from providing the relevant context to the model, because LLMs do not remember what was discussed in the past. You specifically have to provide that as the context to them. So through the Converse API, we have ability to easily do that. And we can see here the response again generates some of the metrics associated with the first message being processed in the second message, and then it shows us the whole message history there. So the role here of the assistant, the text is being provided here, right? Because first message was us asking how would you distinguish between the understanding language and simulating understanding. Then the next response was from the assistant or from the AI, from Claude, and this was its response response. And then as we go further there, next we arrive to our second question. Is there any potentially interesting angle that you haven't considered? And then the response from the assistant where it says, you're right, to push for deeper exploration. Here are some angles I hadn't considered, and it kind of talks about those in a bit more depth as well. So this is how you can use, and we're just using the standard mode here of 3.7 Sonnet through Converse API. You can see it becomes very easy to construct these conversations and have it be an ongoing conversation with the LLM. Now, similar to what we've done before with the inference, with the invoke model APIs, let's see how we can enable or use the extended thinking mode there as well. So the way we can accomplish that is by going to extended and going to setting the thinking mode to extended, and I'm going to set a bit more challenging prompt now. I'm going to use the system prompt of your mathematician only discuss safe topics in mathematics. And then the message in this case, I'm just providing one message, is are there an infinite number of prime numbers such that n mod 4 equals 3? The same prompt that we've used previously. And I'm going to run this because similar to the previous methods we used for extended thinking mode, this is going to take some time to generate. So we can see here that we're going to append this to the message, and we're going to call the same helper function as before, generate conversations. But now we're going to specify the thinking mode, which we set earlier to extended, and we're going to specify the max tokens to a much larger value, and the thinking budget to 9,000, which is going to override that default of 8,000 that we've set up above. And then we collect the response, same as before, and we print what the response is. Now, this brings us to the end of this walkthrough. Again, I try to, for the sake of your time, keep this very, very time efficient, so it doesn't take long, doesn't take a lot of your time to see how you can interact with this brand new model from Anthropic, again, released about 24 hours ago by Anthropic, and a few hours after that, support for Bedrock released by AWS. The entire notebook is available to you. I'll include the link, so you can clone it and you can review it yourself. And as the 3.7 Sonnet is still generating the response, let's just recap what we've done here. In this particular notebook, we saw how we can set up the clients to different types of clients for Bedrock and Bedrock Runtime. We saw how we can enable access to the management console, and ultimately we played around with the model in the playground as well in the management console. And then we saw how we can run basic inference requests, how we can stream responses, how we can utilize the extended thinking mode for that more complex reasoning from the coding and math perspective, as well as how we can use the Converse API here at the end. Meanwhile, we received the response here from the we received the response here. You can see substantially more tokens have been utilized to generate this response, again because of that extended thinking mode that we've enabled. So there you go. If you'd like to dive a little bit deeper into the Bedrock and learn a little bit more, I'm going to include a few links for you to review that as well. So if you just navigate to skillbuilder.aws and you search for Bedrock, you can utilize the filters here, and we can set price to free because we always want to start from that. And you're going to find some learning plans and courses that are pretty interesting here. So for instance, this blog post from my friend Brad recently got published just about a week ago on how to interact with the Amazon Nova models that got introduced at the reInvent last December of 2024. You can also explore the generative AI learning plan for developers. That's a pretty good learning plan that will walk you through how you can use Bedrock for a variety of different types of purposes, and then skim around, see what else you can find. There's quite a bit of interesting examples there. If you're ultimately planning to get certified, the AWS AI practitioner is a really good option to consider. And then there's going to be we can search for let's search for AI practitioner learning plan. And there's going to be an entire learning plan that walks you through right here. This one, standard one, is the one that's available at no cost. You can see it has about 18 hours of content, and it's going to give you plenty of material to review and learn both on this topic as well as to prepare for your exam. So again, if you haven't checked out that DeepSeek video, I'll include it here above, and make sure you subscribe and like, and I'll see you on the next one.